Today we'll look at ways to evaluate limits algebraically, so without a graph or a table. And let's review what the difference between a function value and a limit. So here the function value at a exists, and it's right here. So we could say that f of a exists. Also, the graph is going to the same place. It's going to that same y value, and we could say that the limit of f of x as x goes to a is the same as the value of the function. And this is how we describe something to be continuous. We've seen that earlier in the year, and a continuous graph is one where you can trace it without lifting the pen. In this problem, f of a does not exist, but the limit of f as x goes to a exists. So the limit is just looking at what value is being approached, and it's approaching this y value from both sides. So the limit exists, but the function does not exist. And here we have f of a exists. F of a exists, it's right there. There's f of a, but the limit does not exist. And these two graphs, these two functions are not continuous at a. This is a removable discontinuity. This is not removable. That's a jump discontinuity. So all we need to have is this, when you're able to remove by canceling, it does what we're going to do today. We're going to cancel some factors, and then we'll be able to remove the discontinuity. So we'll be focusing on this type of function today. Properties. Limit properties. They're on page 746 with the formal notation. Let's just look at some of the big ideas. If you have the limit of a function as x goes to 4, you just put a 4 in there, and that's the limit. If we have the limit as x goes to 4 of polynomial, the properties of limits allow you just to look at the limit of each part or each term. So the limit of this is 16. We put a 4 in there, the limit is 12. And as x goes to 4, 7 just stays 7. And we get 21. So we can just put the limit inside the radical. Limit as x goes to 3, 8 minus x. So we just substitute 3, you get a 5, and so the answer is radical 5. And that's all evaluating limits with direct substitution, so that's some vocabulary that will be used. All right. Pause the video and evaluate these limits. So if we evaluate that one, we can put the limit inside as x goes to -1. And we just put a -1 there. So -1 plus 3, 2. And we just get radical 2. Here we're just going to, we can do the limit of the numerator. The limit of the denominator. Just by substituting a 2. Now we have 2 minus 3, -1. Put a 2 in here, we get -9. So the limit is 1/9. All right, so that's there's not much algebra there, or maybe no algebra. And this is where we need some algebra. All right, we always start by substituting. And if we put a -2 into all of these x's, or substitute -2, we have 0 over 0, and that's called an indeterminate form. Meaning it doesn't tell us anything about the limit. We have to rewrite this and then reevaluate it. So when you have polynomials, you're going to factor. So we can factor by grouping. Let's take an x squared out of these two terms. And we'll take -4 out of these two terms. And now we have a common factor of x minus 3. Our goal is to be able to cancel the denominator, so we have to keep factoring. So we factor the binomial, the difference of squares. We can factor it like this, and now we see what cancels. And with no denominator, then it won't be undefined anymore. And now we substitute. After you cancel, then we substitute, and we get -4 times -5, which is 20. Now, since when you get this indeterminate form, it's going to be a removable discontinuity. It allows you to factor. Here we are removing the factor that created the discontinuity, and so we say that -2 is a removable discontinuity. And if we graph this, it would be there would be an open circle on the graph at -2. Pause the video and try that one. So when we put a 6 into all the x's, we get 0 over 0. That's indeterminate, so we have to factor. We can factor the numerator as x minus 6, x minus 1, and the denominator 3x plus 7, x minus 6. And if you need to review the factoring, in the denominator we would have 3 times, that would be a 120, 132, and then negative 11. We need numbers that multiply to get 132 and add to get negative 11. From there we go down here, and then you would continue factoring with this. That's not 132, it's 126. So negative 126, 3 times 40, 120 plus 6. So that's a method you can use to factor this. And we see this cancellation. Then substitute a 6, so we get a 5. Put a 6 down here and we get 25. The limit is 1/5, and 6 is a removable discontinuity. And that's how we deal with polynomials. We also have a similar strategy for radicals. So here we'll always start with direct substitution. That means put a 9 in there. Radical 9 minus 3, 9 minus 9. 3 minus 3, 9 minus 9. That's indeterminate, so now we have to rewrite this so that we can cancel, and we do that by rationalizing. Wherever the radical is, we're going to rationalize that. So in square root of 3, that's an irrational number. That's why we call it rationalizing, because we'll get rid of the radical. So we multiply by the conjugate of this. If that's subtraction, we want addition here, top numerator and denominator. And remember that when we multiply these, this is x, negative 3 radical x, negative 9, 3 radical x. We chose that addition so that when we add this we get 0, and then we're left with x minus 9 in the numerator. The denominator also has x minus 9, and we're not going to distribute. So that cancels. And now we substitute a 9 here, so that'll be square root of 9 is 3, and we get 1 over 6. And we can say that the limit is 1/6, and x equals 9 is a removable discontinuity. All right, pause the video and try that one. Put a 25 in there and we'll get 25 minus 25 is 0. Put a 25 there and we get square root of 25 is 5. 5 minus 5 is 0. Indeterminate. So that means we have to rationalize. We rationalize wherever the radical is, that's what we're going to rationalize. Make sure we use the opposite operation. So when we multiply this, we'll have, we better do that over here. No, we're not going to expand that. But when we multiply this, leave this the way it is. Leave that the way it is. And now multiplying the denominator, we'll get radical x times radical x is x. Negative 5 radical x, positive 5 radical x. That adds to get 0, and we're left with that. And that cancels. So when you put a 25 here, we'll have 5 plus 5 is 10. And the limit is 10. Removable discontinuity at x equals 25. Pause the video and try that one. Remember to rationalize the radical. When we substitute a 0, we'll get square root of 4 is 2. 2 minus 2 is 0. Substitute a 0, we get 0. That's indeterminate, so we rationalize. We want to rationalize this radical, so we have to go 2 plus x plus 4. We don't change the operation inside the radical, it's just the operation outside. And multiplying the numerator, we get the 4. This is going to be a negative or 2 radical. Positive 2 radical added, you get 0. And then we get this radical times radical is x plus 4. Four minus x minus 4. 4 minus x minus 4. So the numerator is just going to be a negative x. And they cancel. So we have a negative 1. And substituting a 0, we get a 4. Negative 1/4. And a removable discontinuity at 0. That's the end of that lesson.